As shown in the figure, a 4 kilogram block is moving at 5 meters per second along a horizontal, frictionless surface towards a spring described by Hooke's law that is attached to a wall. After the block collides with the spring is compressed a maximum distance of 0.68 meters. What is the speed of the block when the spring is compressed to only 1/2 of the maximum distance? So 1/2, that's pretty important. And there's some other things with this problem that we need to know too. The maximum distance, the weight of the block, and how fast it's going. So let's just write down these values pretty quick so we have them. So mass is 4 kilograms. The velocity is 5 meters per second. And the max x is usually used for distance. I wrote a. The max x is 0.68 meters. Now there's two equations that we can plug these values into. So one is the spring constant, K is equal to 1/2 mv squared. And the other one, which we aren't going to use just yet, is potential energy of the spring is equal to 1/2 kx squared. So these are pretty similar, but you need to have one to be able to do the other. Since we already have our mass and velocity, I'm going to do this equation first. So K is equal to 1/2 4, we have that for our mass, and 5 for our velocity, squared. K is equal to 1/2 of 100, because 4 times 25, 5 squared, is equal to 100. K times 1/2 is equal to 50. 50 N over M, newtons over mass. So knowing this, we can find the answer to this equation. Because we don't know what the K is for this problem yet. So 50 is equal to 1/2 kx squared. 50 is equal to 1/2 k. That's the value we don't know yet, because this is for the final. Is equal to 0.68 squared. 0.68 is our x. That's the maximum distance it can be stretched. 50 is equal to, I gotta do this with my calculator real quick. 0.68 squared times 0.5, 1/2, is equal to 0.2312k. So I'm going to divide 50 by this, and we're going to get 216.26. That's the number I'm going to use. So you might wonder why that's so big, but if you plug it back into this original equation, it should also equal 50. I'm going to test that right now, actually, just for proof. So 2.26 times 0.68 squared divided by 2, 1/2, is equal to 49.99, which is 50. And this is due to the law of energy conservation. So K1 plus US1 is going to equal K2 plus US2, because the energy's, it's never leaving, it's always going to be there. So it may become bigger, as you can see here, but it's still the same kind of, it's still using the same numbers. It's going to equal the same thing. That's what I'm trying to say. Okay, so now that we know this, we have to figure out what the speed is, because we have our information for this. So now that we've done the US equation, we have to figure out what the K equation is for this. So 50 is equal to 1/2 4 that's the mass, so that's going to apply either way. And then v, this is the velocity for after the equation is finished. And then plus 1/2 k 0.34. Now you might be thinking, hey, why is this number different than that one? Because aren't they both the x? And that's true, but as you might remember earlier, it said 1/2 of the maximum distance, so that's the equation we have to use here. Luckily for us, we already figured out what k is, so we can just plug that into here. So that equals 50 equals, I'm going to change that to 2v squared because 1/2 of 4 is 2, plus 12.5. If you plug in the numbers and do the math, you'll get 12.5 for this. 50 minus 12.5 is equal to 37.5 joules, and that's equal to 2v squared. So we should just divide by 2 now on both sides. 37.5 divided by 2 is equal to 18.75 v squared. And then to finish this, we just need to square root both sides. 18.75 square rooted is equal to 4.33 is equal to v. V is equal to 4.33 meters per second, and that is the speed